Hi, I'm Larry Lancaster, founder of Zebrium. Today I'm going to show you how Zebrium delivers autonomous monitoring to you, and that's through what we call incidents. So you see I'm logged into the Zebrium UI here. In this particular account, we're using to monitor our in-house Atlassian stack that we use for development. So you can see I'm on the incidents tab in the upper left. Here you see that I'm looking at today's open incidents, and there are none. There were none yesterday either. But if I go to all time, I see any open incidents that correspond to my retention period, and here I see one. Now, what you'll notice, and typically if there was more than one incident that was open, you would see entries like this tiled down the screen. And what this is trying to tell you is the worst thing that happened in that incident. Um, uh, and that's so that you can quickly at a glance tell if this is something you should look at right now. And what this event is telling us is that it was taking more than a minute to access a Confluence page. So clearly that's a bad thing, and we're going to want to take a look at it. Let's drill down. So this is what an incident report looks like. To give you a little context, Zebrium doesn't require any sort of parsers, configuration, connectors, or alert rules. In fact, we don't want them at all. Everything that we do in terms of teasing out the structure and what is an incident and what isn't, we do autonomously. So what you can see here in this incident report is at the top, we've listed out the log types and the hosts that have participated in this incident that our software has identified. And if these were container logs, these would be, rather than file names, these would be sort of truncated container names. Regardless, this is giving you a sense of the services that are impacted or involved. Now, what you can see here when we look at the incident report, let's take a look at the logs first. There's going to be two kinds of logs that Zebrium pulls out and puts into an incident. The first are rare events. And the way we figure out what is rare is we keep track of the type of every event. So if you were to look here, you can see the event type is invoked OOM killer. So every time an OOM killer is invoked, there will be an event of this type. So we have a unique dictionary of the log types. And so we can tell when a rare event happens. We can also tell when there's a rare value for a parameter in an event, as an example. And so we'll use rareness as a cue that there may be a potential incident here of interest, but that's not enough. We also need to find in a separate log stream something bad. So what we're looking for is correlation with rare things in one channel and bad things in another. So what we're detecting is the sort of thing that an SRE would find if they were new to a stack, right? They'd say, oh, this looks rare. This is weird what I just saw happen over here. Oh, and then right away something bad happened over here. Maybe that's related. And so what you'll find is that's kind of how Zebrium operates. So what you're seeing here again is that sort of hallmark event. That's the worst thing that happened, which is the 1 minute access time to Confluence. And the temporal proximity of these is why this incident was created, this rareness and this badness. So now if we look over to the left, we'll see some metrics which also correlated with this incident. You can see this white dotted line that corresponds to the time of the first event here. And so what this is showing is that just before this OOM killer was invoked, there was a lot of CPU utilization, and then it stopped right away, which probably indicates that whatever was using the memory was using CPU as well and got killed. You can see other interesting metrics here. For example, this probably indicates some swap activity. If we scroll down, what we'll find is this is really interesting because we'll notice that the Postgres transactions dropped to 0 just before the OOM killer was invoked, telling us that the out-of-memory condition was probably impacting Postgres, which is why Confluence couldn't serve pages. And then finally, you can see all the guys that got swapped out, all the processes that got swapped out. Once the offending process was killed, they slowly paged back in. So at a high level, that's how Zebrium works. That's how it monitors things, and that's how it delivers value to you, is through incidents. Thanks for watching.